Okay, we'll look at a program called Fritzing in this video. Fritzing allows you to create a schematic and actually have it fabricated. So the important part about this is not really the fabrication itself, but being able to articulate how that would be fabricated. Because in this section, in section C, you need to provide all the instructions for a third party to actually make your circuit. So you normally end, if you download that Fritzing file, you'll start with the welcome, and the first thing you should really do is go to the breadboard. So I'm just going to maximize the screen. Now, core parts, there's a huge library of parts. Sometimes you're not going to be able to find the chip you're looking for. So what you can do is, if you go into search and then type in so if I type in a generic IC, and it's right at the very, very end. Now, this one is a chip, and I can customize it. So if you've got a chip that you don't know what it looks like as a schematic, then what you do is, if you just type in generic IC, and then you click on that, you can actually change what it's called and how big it is. So if you've got something that required, let's say, 2 inputs and 2 outputs, well, then you've got 4 pins. So I just changed that to that, and I'm just going to delete those there. Let's zoom in. Okay, and if we say that your chip was a 433 megahertz receiver, well, now you can actually change that label, which is just down there, to 4. So that's just down there if you missed it. 433 megahertz RX. Okay. Another good thing you can do is you can actually label those pins. Edit the pin labels. So we could say that, well, this was the in, and that was positive, and pin 2 was the out, positive. Save that. Okay, so now what you've got is you've got your pin numbers, and we can now rig that up to a battery. So let's zoom out a little bit. Okay, well, let's get a battery. And the battery you wanted, let's say, was a 9-volt battery. You can choose different batteries. There's loads of others. All right, let's say we've got a coin cell battery here. So we put the coin cell battery there. If we just hover over it, that's the negative. So I'm just going to drag a wire to the negative sign. And if I hover over that, that's positive. And drag that one to the positive sign. So red is positive, and the blue in this case is negative. And if I hover over that, well, that's negative in. So this one should go to there. And if that's the in negative, then this one go here. And let's say that when this came through, it was turning on, I don't know, an LED. Okay, so if I just type in 5D, I'm just going to drag that over, and I'll take this one. Right. So this one, if I hover over it, is negative, and of course if I hover over that one, that's the cathode. Cathode is negative, so I can go here, and then of course positive means that it has to go there. Alright, so it's very, very, very basic. Alright, so you've got that. This is your virtual model. That's not connected, is it? Okay, there you go. Alright, so just make sure everything is green. Okay, so there's my chip, there's my battery, and there's my LED. And I'm just going to rotate that to make it easier. Okay, let's get these dotted lines into solid lines. Right, this is called a schematic. Okay, a very, very basic schematic, but it is a schematic. All right, so once that's done, I would screenshot that because that is the circuit diagram. let's turn this into a PCB. The quickest way of doing this is if that's where the battery's going, and this is where the chip is going, we're trying to get these lines to not cross over. Okay, and because of dematerialization, a smaller case for it. There you go. You can drag these out, and these would be your copper tracks. All right, so there's a very, very basic one. Now, let's say that it was very, very complicated. So I'm actually going to remove all these tracks. So select all the tracks, and then just press the delete key. Now, if I go auto route, that does it automatically. Okay, so this is one layer, so that would be like the top of the PCB, and that might be at the bottom of the PCB. Once you've done that, if you go to fabricate, and we're going to upload that for you. So if we just open that in a browser. So this is what the top of your circuit would look like. This is where you put the components. So your battery would go there, the chip goes there, the LED goes there. And underneath, so a mirror image, underneath would have these holes for these components to go through. So that's one important part. It also gives you the dimensions, gives you the surface finish, and how many layers of copper. At the moment you've only got 2, so that should be quite easy. If we now have a look at the actual PCB itself, this is what it will look like on the top. So this is a stencil, and it tells the manufacturer or the assembler exactly where the components are going. These are the copper tracks, and these are the holes. Okay, so these are the holes that we looked at first. Now, should be able to put those back on, and you've got your measurements there as well if you need it. That's your BOM. So this is your bill of materials. Okay, so if you've been doing an Arduino Nano, you type in Arduino. So your Arduino Nano is version 2. Okay, I'm going to turn that around so the pins are either side of the breadboard. Now I do everything by breadboard, but you don't have to. You can go directly into it. So you've got your 6 volts. Sorry. Take that one, and I'm going to go to ground, which is there. Is that ground? Just move that around a bit. Okay. And now I'm going to move that around so that it's a bit neater. All right, so there's that's your circuit, not a circuit diagram, but your pictorial circuit diagram. Then you can put your schematic in here. Okay, so that's done, and now of course I can go and fabricate that and send it there. You've got the price per board, you've got your scales of economy down here. So if I buy 1 board, that's $7.89, but if I buy 12, that's only $1. This is all important stuff, so you want to screenshot this as well. Okay, now the last part then is, if I look at the Arduino Nano, the processor is an 80 mega. This is only advanced stuff. This is for your commercial production. If I type in 80 mega, that's the raw chip, okay? So what happens here is I'm buying the chip, I'm not buying the board. Now, the board has lots of different chips in it, which makes it versatile. But theoretically, you should be able to make anything with the raw components themselves. There's another one. Okay, so you can, for the commercial production, not for the prototype, actually go and choose the raw materials as opposed to prefabricated prototyping materials. But like I said, that is advanced, but it does need to be considered. It does need to be considered for the commercial production.